All right, everybody, hello. Today we're going to talk about the pressure tester, and more especially how to use it on an engine. In this case, for display purpose, we made this engine rig. And today I'm going to show you how to use the products on this engine rig. I would like to remind you to have a look at the first video we made because this is the best introduction to the tool. Today, I'm not going to show each and every adapters on the kit. I'm going only to show you how to use it on the engine rig. I would like also to mention the fact that you have two sensors included in the kit, while on the engine, you will see that there are many sensors already mounted on the engine. This is only for display purpose. This is much easier to have them already mounted on the engine than having to connect and disconnect everything all the time. And that's it. Let's go to the tests. Okay, and the first test we are going to make is the compression test. To make the compression test, you have to put the false injector here. So we already set it. It's sitting in place of one of the injector on the cylinder on which you want to take the measurement, of course. And we are going to connect the 0 to 300 bar sensor. So I'm connecting the cable that comes from the sensor. And I can crank the engine. If I want to go to the second cylinder, I would have to disconnect it, reconnect it. I'm connecting to the same on the display, of course. Go to the second here, and cranking again. Of course, it gives almost the same value because this is the same cylinder. This was the compression. The second we're going to make is the fuel low pressure. Okay, here we are already connected with the adapter. So on the engine, on the car, the line would go here to there. We just disconnected it. We put the T adapter here, which allows to take the measurements with this sensor, the metal sensor. In this case, this is the adapter number 1. It could be another one on the other engines. I've already connected the right wire, fuel low pressure, okay, and I'm going to activate the pump. It always remembers the maximum value. The third mode I'm going to show is the turbo pressure. Here, I already connected the right wire. In here, this is this adapter, the plastic adapter, and we are connected to the turbo. Of course, to make the measurement, the engine should be running. So in here, I'm going to simulate that the engine is running using a pump. So, okay. And here is what you would read if the engine was running. So you have the reading of both the vacuum and the low pressure. And it remembers the lowest and the highest. Now for the ADBlue pressure. The connector is here. So we, just like on the second example, we use one of the T adapters. So the line of the car should go directly there. We removed it and put the T adapter with this sensor. In this case, this is the adapter number 3. So this is the line that goes directly on the ADBlue injector on the particulate filter. It's connected. And I'm going to activate the pump. For the next test, we have the cooling system pressure. Well, we can't test this on the engine because, of course, this is an engine rig only. We don't have some liquid in the engine. Loss of cylinder pressure, this is an optional set that will be available soon. It's not available right now. So let's go to the common rail pressure, fuel high pressure. I need to explain a bit before we go on the engine rig. So we have three optional sets. The first one is the one you will need in any cases, is the one with the sensor, the 2000 bar sensor, that will allow you to make the measurements with the two hoses. So, with this, you could disconnect the line that goes from the pump to the common rail. So you remove this line, you connect the hoses with, in the middle, the sensor to make the measurements. You could also measure the pressure from the common rail to one of the injector the same way. I'm going to come back to this when we go on the engine. With this set and this set, actually, you will locate, the purpose is to locate an issue on the common rail system. With this one, it's only, the first one, it's only a measurement. So, let's begin with this one. This one will help you identify if you have a problem with the regulator on the pump. So, you remove the regulator and you put one of these dummy caps. And with the first one, you take the pressure and you will see if you come back to a normal pressure. That would mean that the regulator has a problem. The other one, the second one here, allows you to block these inlets, these fuel inlets that goes from the common rail to the injector. The purpose of this is to locate a faulty injector. Let's remember that the injector might leak from the return line, but they also leak in the combustion chamber. With the previous kits where you collect the fuel that goes on the return line, you cannot, of course, see what goes directly in, what's leaking directly into the combustion chamber. With this one, no problem. So you are connected here with the first one, the first kit, the hoses and the sensor. You block, let's say, those three injectors, and you let only this one connected, and you go from injector to injector to identify where you lose the pressure. So let's get back on the engine. Here we are connected. We are connected on the full pressure of the pump because we mounted the cap in here. The other thing we did is to already mount one of the dummy cap to remove, to bypass the regulator here. So the pressure I'm going to have right now is what we call the real pressure, the full pressure of the pump, which should be around 1,300 bars. In this configuration with the cap here, we have the real pressure, as I just said. Some will say that we are supposed to be reading 1,900 bars of pressure. That might be true, but we have the information from the manufacturer of the pumps, which are Bosch, Delphi, and so on, that if we have 1,300 bars of pressure, we have enough pressure for the common rail. It means that the pump doesn't have a problem. So what we did in order to have a safety margin with both the sensor and the hose, which are 2,000 bar approved, we have a release valve, which is a 1,300 bar. So it means that when the pressure approaches 1,300 bars, the fuel will be redirected here to this small reservoir. If we want, we can make the engine run. So in here, of course, the engine will not run because we don't feed the engine with fuel. If we connect the second hose from here to the common rail, we can make the engine run. So let's go back on the screen. I'm connecting the sensor. Fuel high pressure. And we have, I would say, a normal pressure. If the second hose would be connected, you will have a running pressure of around 300 bars. And in case I wasn't clear enough, these 3 sets are for diesel common rail only. The gasoline common rail adapters will come very soon. Now for the vacuum test, we are going to connect the low pressure sensor, the plastic sensor, and we are connected directly using the adapter number 6 directly on the vacuum pump. I already connected the right one, and I'm cranking the engine. Now for the oil pressure, I cannot unfortunately make the test on the engine rig because the engine doesn't have the oil radiator, but we would have to connect this adapter number 2, which is already a 90-degree. Much easier when connecting on the radiator. And now for the last mode, the last test we are going to make today is the particulate filter. You know that on the particulate filter on a car, the car calculates if the filter is blocked using a differential of pressure. For that, there is a hose after the filter and a hose before that goes to the differential of pressure. In this case, we are going to use the hose before the particulate filter, and we are already connected with the plastic sensor. So here, I'm simulating using this, a blocked or not blocked particulate filter. The first one I'm going to make is fully open. It's in the green. I'm looking at it a bit. Still in the green. A bit more. It's actually closed. And that's it for today.